Today I'm going to explain about test case designing techniques. First, we'll see what is software testing designing techniques. Actually, it helps testers to create efficient test suites. They are the strategies that helps to write better test cases, and it helps testers to create fewer tests while ensuring the broad requirement coverage. As well as we can choose these test designing techniques based on some factors. They are the type of the system, level of risk, what are the testing objectives, and timeline and the budget of the project. There are more test case designing techniques, but today I'm going to discuss about these 5 techniques. The first one is boundary value analysis. The second one is equivalence class partitioning. And third one is decision table. Fourth one is state transitioning. And the fifth one is error guessing. We'll see these one by one with the example. The first one is boundary value analysis. In boundary value analysis, access the values at and beyond the edges of a range of expected input. It generally seen that a large number of errors occurred at the boundaries of the defined input. As a tester, they can write test cases which exercise boundary values. The boundary values analysis is based on testing at the boundaries between partitions. It includes maximum, minimum, inside or outside boundaries. We can take an example like this. If a text field, in a text field, we can enter value between 1 to 10. Then boundaries should be 0, 1, 2, and 9, 10, and 11. The second test case designing technique is the equivalent class partitioning. In equivalence class partitioning can help QA teams to reduce the number of test cases without hurting the test coverage. This test case designing technique organizes test data into groups. Each member of the group we can consider each of member of the group give the same result. If one member of the group fail, then we can consider all the group failed. If one member of a group is passed, we can consider all the values in that group is passed. Then we no need to write test cases for every number value of the group. Yeah. As an example, we can get like this. We can consider a text field, get values between 1 to 10 and 20 to 30. In here, we can have 5 equivalent partitioning classes. The first one is minus value to 0 values. The second one is 1 to 10. And third class is 11 to 19, and fourth one is 20 to 30, and fifth one is 31 to plus 31. In these 5 classes, we can select one value of each classes. From first class, we can get -2. The second class, we can test number 3. For the third one, we can get 15. And fourth one, we can get 55. And the fifth one, we can get 45. The other technique is decision table based testing. In this software testing, technique is used for function which respond to a combination of inputs or events. The first task is to we have to identify all the functionalities where the output depends on the combination of inputs. If there are large number of combination, we can take separate decision tables for each. But we have to take one decision table for one functionality. These are the steps to create a decision table. First we have to enlist the inputs in rows and enter all the rules in the columns. We have to fill the table in the different combination of inputs, as well as the last row we can note down output against the input combinations. We can take this example. We can consider login button should be enabled after we entered the required field. In here, as inputs, we can get username and password. For the output, we can get the login. Based on this username and password field, we have 4 rules for this decisions table. Rule number 1 is if what happened, user enter incorrect username and incorrect password, then login should be failed. The rule number 2 is username is correct, but the password is incorrect. Then again, login will be failed. The rule number 3 is username is incorrect, but the password is correct. Then again, the login will be failed. The rule number 4 is user enter both the username and password is correctly, then login should be passed. Likewise, we can make decision tables. The other technique is a state transition. These testing techniques allow the tester to test the behavior of an application under testing. The tester can perform actions by entering the various input by sequence. User can test the system by adding negative and positive values and test the negative inputs and the positive inputs, and they can test how the system is behaved. For guidelines, the state transition should be used when a testing team is testing the application for a limited set of input values. We can get this example for that one. We'll check how this account will be behave with these input values. First, user can log in, and for the first time, he can enter correct password. If he enters a correct password, then he can successfully log into the account. If first attempt he enter incorrect password, then he will direct to a second attempt. In second attempt, if he enter a correct password, then he can successfully log into the account. If not, he will give another attempt. Then in here also, if for the third attempt, if the user enter the correct password, then he can successfully log into the account. If not, then for the third time, if he enter incorrect password, then account will be blocked. This state transition table is based on the previously discussed the image diagram. This state transition table show how the states are displayed here, changing according to the login attempts and correctness of the password. If user enter incorrect password for the third time, then account will be blocked. If not, if he enter the correct password, he can successfully log into the account. The last one is error guessing. In error guessing, a QA engineer, in error guessing technique, a QA engineer predicts where errors are likely to appear, relying on the previous experience and knowledge of the system and product requirement. Based on this technique, counts a list of possible errors or error-prone situations. Then the tester can write test cases to expose those errors. These are the guidelines for error guessing technique. The test should be use the previous experience of the testing similar applications, as well as understand user have to understand the system under test, knowledge of the typical implementation of errors before, remember previously troubled areas, and evaluate historical data and test results. As an example, we can get such as entering blank spaces in the text field, what happened pressing the submit button without entering data, or entering invalid parameters. We can take this example for error guessing. These are the importance of the test designing techniques. This test designing techniques basically help to select good test case sets, and it's reduced the total number of test cases and give a good coverage for the system, and it helps to develop to get detect more errors, and it saves the testers time as well. Finally, I want to say these are the test case design. These test case designing techniques can be categorized under 3 categories. The first one is based on deriving test case directly from the requirement specification of black box test designing technique. The techniques include here are the boundary value analysis, equivalent partitioning, decision table testing, state transition diagrams, and use case testing. In my presentation, I most of the cover this black box testing designing techniques. The second category is deriving test cases directly from the structure of a component or system. This one we will be categorized as the white box testing as well. For this one, these are the techniques under this category: statement coverage level, branch coverage, part coverage, LCSAJ testing. The third category is the deriving test case based on testers' experience on similar system or testers' intuition. For this category, there are 2 techniques, error guessing and exploratory testing. And that's all. And thank you.